In this video, we're going to talk about how we can quantify electrolysis. We can calculate how much material we produce by electrolyzing at a particular time. So, quantitative electrolysis is really like a stoichiometry problem. We can use current and time to work out how many electrons were transferred, and we can use the number of electrons in the stoichiometric ratios to work out how many moles and therefore how many grams of a product are produced. Now, in order to make this make sense, we're going to need to think about some units. So I remind you that an amp, a unit of current, is equal to 1 coulomb, this is the unit of charge, per second. A reminder that a volt is a joule per coulomb, and so a joule is a volt times an amp, or actually a watt, sorry, I was wrong about that. A watt is a volt times an amp. And I also remind you that, so this one's really important, and then here this one is really important, that a Faraday is 96,500 coulombs, the unit of charge, so coulombs, per mole of electrons. Those are going to be useful factors. Let's see how they work together. So, one way you could use electrolysis is for electroplating. So in this case, we add a voltage source to a solution of silver ions, and if we dip in a spoon and assign that to the cathode side, the negative side of the reaction, then reduction will happen at the surface of that electrode. So silver ions from solution will get reduced to silver metal on the surface of the spoon. So we can coat or plate a thin layer of silver all over the spoon. So we can calculate here, if a spoon is plated with 86 milligrams of silver from a solution of silver nitrate, and if the current is 1.2 amps, how long would it take us to plate each spoon? Okay, so here let's start with, we've got 86 milligrams of silver. It's more useful for us to work in grams probably, so we're going to convert that there are 10 to the third milligrams in 1 gram. Okay, and then we can convert those grams of silver into moles using the molar mass. So 1 mole of silver equals 107.87 grams of silver. All right, for every 1 mole of silver, we transfer 1 mole of electrons. And how do we know that? If we draw out the half reaction, we know that silver plus an electron goes to silver solid. So that number might be different depending on our reaction. So 1 mole of electrons for 1 mole of silver. And we know that Faraday's constant tells us that there's 96,500 coulombs per mole of electrons. Finally, we know that 1.2 amps is 1.2 coulombs per second. So if we put all that together, I get that this will take 64 seconds. So if you set up your process so that you want to put 86 milligrams of silver on each spoon in order to completely coat it, then at a current of 1.2 amps, you're going to need 64 seconds. Fun fact. Okay, but so maybe you're not in the spoon plating business. When would you ever see an electrolytic cell in real life? It turns out that you see electrolytic cells all the time. When you charge your phone, your battery, a voltaic cell, is running in reverse an electrolytic cell. So rechargeable batteries can go in both directions, both galvanic and electrolytic. So when you plug your phone in, you're converting that electrical energy into stored chemical energy. Another big place where we use electrolytic cells is in the Hall-Héroult process for making aluminum. So it used to be that aluminum was considered to be such a precious metal because we could find aluminum oxide, the mineral bauxite, all over the Earth's crust. It's really abundant as an element. But it was always as aluminum 3+. It was really hard to get it to be aluminum metal. And so in the late 1800s, there were two different groups who simultaneously worked out how to produce aluminum electrochemically. One of those people was Charles Hall, who was a student at Oberlin College, and working with his sister Julia Hall, who also went to Oberlin College, they basically, as their undergrad research project, they worked out and the foundations of the electrochemical production of aluminum. So in this case, we reduce the aluminum by adding electricity. And so we're able to make a whole bunch of aluminum. This process, so Charles Hall formed a plant for making aluminum at industrial scale near Pittsburgh, and that was the beginning of Alcoa, the Aluminum Company of America. So yeah, every time you use aluminum foil, think electrolysis.